If I asked you what an electric vehicle, a solar panel, a wind turbine, and a fighter jet have in common, you might say advanced technology. But the real answer is they all depend on a small set of minerals that the world does not have equally distributed. That's the hidden bottleneck in the clean energy transition and modern manufacturing, critical minerals. Because if you don't control the ingredients, you simply cannot control the future. That's why India has launched the National Critical Mineral Mission, or NCMM, a mission designed to secure supply chains and build India's value chain capabilities from exploration all the way to recycling. By the end of this video, you will know exactly what NCMM is, what India plans to do, and which key industries stand to gain or struggle. So, let's simplify the phrase critical minerals for a moment. A mineral becomes critical when it is absolutely essential for our economy, technology, or national security, and its supply chain is significantly risky. This risk comes from supply being highly concentrated in just a few geopolitical regions, creating dependency for everyone else. Modern industries today don't just run on steel and cement, they run on specialty materials like lithium, cobalt, and rare earths that power batteries, magnets, and chips. India has officially identified a list of 30 critical minerals, with 24 of those now given special legal treatment under the MMDR Act for central government auctions. This special scheduling means the government takes a direct and exclusive role in auctioning the mining leases for these vital resources. To put this into perspective on screen, these minerals are essential for our energy, electronics, defense, and overall industry. Now, let's look at what the NCMM mission itself actually entails. Launched in 2025, the NCMM is the overarching strategy to build a completely self-reliant critical mineral ecosystem for India. It has two incredibly big goals. First, to secure supply chains, both domestically and through overseas assets. The second goal is to build out the entire value chain, which means processing, recycling, research, skills, and financing must all be developed internally. You can visualize this entire mission through its 7 interlocking pillars, covering everything from production to financial incentives. This is not just about finding rocks. It is a full-stack industrial play meant to create deep capability across the board. Now, let's look at the targets that truly reveal the scale of ambition for this mission, running from 2024 to 25 through 2030 to 31. The plan calls for an aggressive 1,200 exploration projects across the country. To secure foreign sources, the target is 50 overseas mines, split between 26 to be pursued by public sector undertakings and 24 by private sector players. The mission also aims for 1,000 patents, 10,000 people skilled, 4 dedicated mineral processing parks, and 3 centers of excellence. Furthermore, the plan includes creating 5 cumulative strategic mineral stockpiles to buffer against immediate global shocks. And critically, the government intends to bring over 100 blocks to auction to unlock domestic mining potential. This entire effort is designed to move value along the entire ladder: exploration, then mining, then processing, followed by manufacturing, and finally, recycling. Now that we know the targets, let's map where these critical minerals actually go in our clean tech ambitions. For solar PV, key inputs are silicon, tellurium, indium, and gallium, directly supporting India's goal of reaching 64 gigawatts of solar capacity. Wind energy magnets rely heavily on rare earths like neodymium and dysprosium, essential for high-efficiency turbines, as India pushes its wind capacity towards 140 gigawatts by 2030. And the entire EV and energy storage revolution is utterly dependent on the battery backbone of lithium, nickel, and cobalt. So, North Carolina M is fundamentally a clean energy enabling agenda, because without these ingredients, all capacity targets become incredibly fragile. Now let's move from the technologies themselves to what this means for the specific industries that will be affected. Let's start with the automotive sector, where mineral supply directly influences battery cost, availability, and the ability to manufacture cells locally. NCMM is pushing supply security for EVs through its 3 main levers: domestic exploration, overseas assets, and closing the loop with recycling. However, here's the important nuance. The value is not just in mining the ore. The real bottleneck is often in beneficiation, refining, and chemical conversion into battery-grade materials. This is why the mission's explicit targeting of 4 mineral processing parks is so critical for moving up the value chain. If the mission succeeds, the EV ecosystem will see more stable costs and predictable supply, making local cell manufacturing more viable. But if processing capacity lags behind mining output, India could still end up importing the refined inputs needed for its growing battery industry. For the automotive sector, the core question NCMM seeks to answer is whether India can truly reduce its input risk in this new electric age. Next, let's examine renewable energy, because building capacity is entirely dependent on securing the necessary supply chains. Solar power needs those specialized materials, like gallium and indium, for photovoltaic cells, directly linking them to India's massive scaling targets. Similarly, the rare earth magnets critical for high efficiency. Wind turbines are tied directly to the goal of reaching 140 gigawatts of wind power by 2030. The narrative here is that India's 2030 clean power goals are not just about building plants. They are fundamentally about securing the specific ingredients for those plants. If India aims for manufacturing leadership in renewables, it must gain control over the material inputs and the processing capability required for components. Now let's look at the quiet giant impacting every corner of modern life: electronics, semiconductors, and consumer technology. These sectors rely heavily on specialty materials and stable upstream supply, making them extremely vulnerable to the supply concentration risks we discussed. The NCMM's focus on patents, centers of excellence, and processing parks signals a clear intention to build deeper, innovative capability beyond simple extraction. For the electronics ecosystem, North Carolina MN's success can directly influence local manufacturing competitiveness and the viability of domestic component supply chains. The biggest unlock here is achieving industrial-grade quality systems and material processing purity, which is why the R&D and CO targets are so important. Moving to national priority, the document clearly frames critical minerals as foundational to economic development and, crucially, national security. Defense and aerospace systems, from advanced sensors to high-temperature alloys in jet engines, depend on specialty metals and rare earth components. NCMM directly supports defense resilience by scaling domestic exploration, acquiring overseas assets for diversification, and establishing those strategic stockpiles. Essentially, the defense impact is about reducing strategic vulnerability in materials that could instantly become choke points during any global crisis. Now, let's talk about the real economy, the winners in the mining, metals, and heavy industry sectors. NCMM creates a massive pipeline of activity for exploration, service firms, survey companies, logistics providers, and beneficiation players. The huge exploration target of 1,200 projects is already driving activity, contrasting sharply with the smaller numbers just a few years ago. The mission is also explicitly encouraging private participation through new exploration licenses to unlock capital and speed up discoveries. This large-scale domestic push means significant employment and industrial capacity growth for the entire allied ecosystem, not just the mines themselves. Perhaps the most underrated chapter is recycling, or what we might call urban mining, driven by explicit NCM incentives. The policy specifically looks at recovering materials from secondary sources like fly ash, mining tailings, and red mud, which is a massive industrial pivot. This directly fuels the growth of battery recyclers, e-waste recovery specialists, and hydrometallurgy players who can extract value from waste streams. Here is a strong punchline for this segment. India may not have everything in the ground, but it will increasingly have critical minerals in its waste. Recycling not only reduces geopolitical vulnerability, but also accelerates supply since it's much faster than new mine development. Finally, we must talk about the often ignored but crucial sector: chemical processing and materials science. Raw ore is just the start, turning it into battery grade or electronics. Grade input requires high purity refining and complex chemical conversion. The NCMM's commitment to 4 mineral processing parks is a direct signal that India intends to capture this high-value step in the chain. This directly benefits chemical processors, industrial EPC builders who construct the plants, and the entire R&D ecosystem needed for process technology. This focus on capability is why the mission bundles targets for patents, skilled people, and centers of excellence together. The hardest part of this transition is not the intent to mine. It is building the sophisticated, high-tech capability to process. Moving beyond domestic geology, India is aggressively pursuing an overseas mineral strategy, a practice standard for resource-hungry nations. This is formalized through targets for 26 overseas mines via SUS and 24 via private entities to diversify supply risk globally. A concrete example is the ongoing agreement involving Kabil and Argentina's Camion for lithium exploration across over 15,000 hectares in Catamarca. Furthermore, India has formalized its intent through a Memorandum of Understanding with Australia's Critical Minerals Office to foster collaboration. The core lesson here is that securing supply upstream by owning assets abroad is standard, necessary global statecraft. This mission isn't being built in a vacuum, as it actively builds upon existing industrial strengths, notably through IRIL India Limited. IRIL is central to beach sand minerals and rare earth processing, boasting a large processing capacity for key materials like ilmenite and zircon. The mission leverages this existing institutional position while pushing for scale-up, specifically referencing their rare earth extraction and refining facilities in Odisha and Kerala. This shows that NCMM is designed to amplify what already exists, not start entirely from scratch in every segment. Now for a crucial credibility check. This mission acknowledges that execution across a complex system is what truly determines success. The reality is that exploration is long cycle. Processing requires immense technical depth, and approvals face real environmental constraints. NCMM attempts to mitigate these by planning for fast-tracked approvals, new exploration licenses, and strategic stockpiles. Ultimately, the mission's success hinges on whether all components exploration, overseas deals, recycling, and processing move forward together in sync. Finally, let's connect the NCMM to India's broader national goals for climate and economic transformation. The mission directly supports the targets for emissions intensity reduction by 2030 and increasing the share of non-fossil power capacity for that same year. The long-term commitment to net zero by 2070 is impossible to achieve without securing the essential material foundation today. The clean energy transition is not merely an engineering challenge. It is fundamentally a minerals challenge that must be solved. And the National Critical Mineral Mission is India's strategic attempt to step onto that crucial battlefield and secure its future growth.